Everybody, it's Tyler here at Space City's signature event. Check in 16689A, the Circuit Breakers. And this is one of the more unique robots I have seen here in High Stakes so far. A lot of great stuff going on. We'll be talking about, of course, their choice of Mecanum wheels, but just overall design philosophy. This team is really trying to hit skills really hard, so we're excited to talk more about how that's all coming into play. But a lot of great stuff. This lifting intake that they have, I'm really excited to talk more about too. Definitely a lot of great unique features, talk about programming, and a lot more coming up here on Pits and Parts. So Jeremy, let's talk about some of your design philosophy on this robot. We were talking here, I'd love to hear that your team is really trying to hit skills hard, and you just got a lot of great unique stuff on this robot. Tell me more about it.
Yes, thank you, Tyler. So I want to talk about the philosophy behind this robot and the reason why we want to choose Mecanum drive and why we choose it. So actually, go back to our Mall America competition, we thought that actually we're trying to hit our scale as high as possible, but it's our intake and all the stuff actually is not catch up to our speed of our Mecanum drive. Therefore, we think that we can improve a lot of stuff from our Mall America competition. And then the reason why we choose the scale, because first of all, scale can qualify to World Championship, and also if it hit a high scale rank, also improving our programming skill and also driving as well. So we practice a lot and we'll try to hit as high as possible on this robot. Yeah.
What skill are you trying to get up to? Like, what's your top skill score in your opinion?
Right now, I think we are in like 10-ish scale, and I try to hit like at least a 110 and 120 as high as possible, and we're top 5 at least.
Very cool on that. So Yu-Chen on here, we talked a little bit about the Mecanum drive, but I'd love to hear more about what was it like to try to integrate these types of wheels into your robot, and just overall using Mecanum, that decision to go that route.
Yeah, of course. So we have these 4 11 watts motors at the bottom and 4 5.5 watts motors on top, and this creates a total of 66 watts. And this motor distribution is kind of perfectly balanced as we distribute one big and one small motor for each wheel. And the motors are relatively centered, so that we save a lot of space on the drivetrain as well. So as you can see, we have a Mecanum drive, and this drive is a really unique aspect of our robot. So throw back to our research from in the beginning of the season, we know that there are a lot of open space on the field, so we want to choose an all-direction drive because the rings could appear anywhere on the field. Actually, for our first robot of the season, we tried X-Drive because we thought it'd be beneficial for the autonomous round due to its fast speed. However, we realized that because it has a special 45-degree inward angle on all 4 corners, that leaves limited space for both the front and back for the intake and the clamp. And also, a lot of times, we want our robot to be able to move horizontally so that it can match the ring's position, and we can improve our the efficiency of the intake.
Gabriel, talk to me about how these Mecanum wheels do come together here, especially with how you're using your gears. I'm interested to hear more about that. And then a couple other things too, the V-shape I noticed for your mobile goals. Love to hear more about that.
Yeah, so more about the Mecanum drive. So I think this will be one of our most innovative and the hardest thing to make on this drivetrain. So as you can see here, there actually aren't any holes here for us to put any screws through. Well, there are holes, but there aren't any ones to securely put a screw on. So we actually customized this special polycarb so we can safely rest this screw on here so that way it won't move around.
I like the making your own hubs essentially for it. That's pretty cool on that as well. And then from a design-wise on here, talk more about this V-shape that you got.
Okay, so more about this V-shape thing. So sometimes we might be a bit off when we go to do the wall stake. And this thing is just to help us slide into the center so we can make our scoring more efficient. And another thing about this is we have a little space in the middle here. This space in the middle is so we don't have to worry about sometimes closing. We don't have to worry about closing the gold clamp when we go score for high stake. And if we had to worry about closing the gold clamp, it would waste more air and more time.
Jeremy, I really like the lifting intake that you have on your robot. I was watching your last match, and not only is it cool, but you were able to score wall stakes quite quickly while doing that too. So talk to me more about that. And then one other thing as well, I'd love to hear more about how the string works with your odometry pods too.
Oh, okay, nice. So actually, we have the 2 stages of intake. Let's start with the first stage. So first thing here, you might wondering why we having the polycarbonate here? Because a lot of things using a C channel and other kind of structure other than just using polycarbonate here. Actually, it's to back to our Mall America robot. We using the full thing is using this C channel, and it's actually have like 3 pound or 2.5 pound. It's a lot of weight. So, and for this robot, it's already heavy now since it's a Mecanum drive. It's pretty heavy on the drivetrain. We want as light as possible. Therefore, we change it to the polycarbonate, and with the angle channel over here and this triangle structure, actually pretty strong for intake in this case. And also, it's due to its polycarbonate, it's flexible. So if hitting sideways, actually can reduce energy from that. Yeah. Let's moving on to our second stage intake. The second stage, as Tyler mentioned before, is a lift intake. Over here, this lift intake. The reason why we choose lift intake instead of using the Lady Brown Mac or other different kind of Mac, because we think that the lift intake you can lift whole intake and score the 2 ring at the same time. This is more efficient not only for a scale, also for a match. And this lift intake, if it's 600 RPM, with as you can see here, it's a hook Mac. So with the reason why we choose a hook Mac instead of using the flexo or any other types of intake, because we think that hook Mac is actually hook the ring into the goal. And that's create more efficiency. But in another case, for example, like the flexural intake, sometimes it does actually go into the goal. You have to wiggle a little bit and then put it in here. So we think that's kind of waste of time. It turned out the hook max is actually the best solution for this robot.
How many charges are you getting out of actually lifting your intake per match? Like how many times can you actually do that?
So actually, you can see here, we have a 2 piston input over here. This separated out to our 2 tank. So one tank is primarily for like our lift intake and our hand. Because our hand mac is only take one times for the end game. We don't need many times. So and we want to save as much as air for the lifting, because lifting is taking like sometimes taking like 5 psi. Even though we want to save like as much air as possible. So, as you can see here, we have a rubber band to actually help us lift the intake, because the intake is kind of heavy. Yeah, so that's why we. I think we'll say like take like 5 psi.
Sure.
Around that. Yeah. Also, you might wondering why we have this big cover over here, this big polycarbonate cover over here, and this big polycarbonate actually is for our rings, to prevent our rings from falling off. So it's go back to our scrimmage with our sister team that if you lift intake. Oh, sorry. So if you lift intake, it's pretty easy to fall off. If our sister team hitting our sideways in any direction, and it's so easy to fall off, and we don't want to happen because we want most efficient as possible. So therefore, in this case, we have this whole cover, and right now, even if you shake a little bit in any direction, anyway, it won't fall out at all. It's performing very great. Yeah.
Overall, this integration has been phenomenal in this robot. Like I said, I mean, a lot of creative stuff, but very functional as well, too. You know, sometimes we talk to, it's great in concept, but isn't really proven. I think your team has done a great job proving that so far as well. Let's start wrap up. Stephen, talk to me about programming strategy, how you're implementing it, and really focusing on the field.
So in our program, we prioritize our speed very much. With our speed, we can get up to 60 points in practice, actually. One of the main components of our program is actually the PID constants. Our PID constants, the goal for that is having the highest combination of KP and KD as possible while still maintaining our overall accuracy. This allows us to transition from one movement to another very seamlessly. The next part is about how we avoid stopping and turning because they slow down the robot, and we achieve this by setting a route to just implement as many straight lines and curves as possible. And this works because for our intake, we don't actually have to be very accurate in order to get the ring into the intake. So we can just be a bit off and go in a straight line so we can be faster. The next part is our odometry. In the back, we used one horizontal and one vertical, and we also have some inertial sensors up here. Our odometry allows us to know where we are on the field at all times and move from one place to another very easily.
You know, the sensors that you have on that, is that helping you compensate for like drift on the odometry pods?
Yes, it helps a lot.
Very cool.
Finally, we have the color sensors in the front. and on the top. So this color sensor is actually for preparing the 2 rings for the wall stake and onto the second stage intake. So this increases the speed of our wall stake mechanism a lot, and is also very useful during driver control. And also we have this color sensor up here, which is for actually for color sorting. We achieve color sorting by the color sensor senses the distance and the color of the ring coming in, and then if it's a color that we don't want, we move the intake back a bit, and then since the ring still has momentum, the ring will want to fly out, and it won't get scored into the goal, and we can just keep going with our intake.
Well, Circuit Breakers overall, this is a fantastic breakdown, so thank you for doing that. There's a lot of great things that teams can learn from this. Best of luck both in skills and here from a competition standpoint. We can't wait to see how you do as you try to qualify for Worlds. So best of luck the rest of the way. Thanks a lot.
Thank you.